In this video, I present the highlights of the keynote address that I gave Third International Conference ICKECS 2025 held at SJCIT Chickaballapur very recently. The title of the talk was on knowledge engineering using data science and artificial intelligence. In this talk, I highlight the significance of data science and artificial intelligence in processing the large amount of data that is being collected in the current generation data products and processed by artificial intelligence techniques to derive knowledge. And this whole ambit of collecting data, processing them to derive the knowledge can be combined and viewed under the bigger umbrella of knowledge engineering. The next decade is going to be knowledge engineering using the existing fields of data science and artificial intelligence. I present to you about how the bigger field of knowledge engineering can be viewed under the help or ambit of what we call data science and artificial intelligence. I also present to you about the significance of knowledge engineering in the coming decade, especially when we are moving into the era of Industry 5.0. I hope you will enjoy the highlighted points in the talk. Thank you.
It is with deep respect I invite our esteemed principal, Dr. G.P. Raju sir, to deliver welcome address.
Ladies and gentlemen, the advent of knowledge engineering and the rapid evolution of communication systems have been among the most defining developments of the 21st century. The ability to acquire, structure and apply knowledge effectively, coupled with the power of seamless communication, has revolutionized industries, transformed the societies and redefined the contours of human potential. It is within this exciting and dynamic context that ICKECS 2025 finds its relevance. The conference aims to provide a fertile ground for the exchange of ideas, dissemination of research findings and the establishment of collaborations that transcend borders. It is our endeavor to promote a spirit of inquiry, critical analysis and innovation, qualities that are indispensable to the progress of science and society alike. Over the course of the next 2 days, we shall witness an array of technical sessions, keynote addresses and paper presentations. Each session has been meticulously curated to ensure the highest standards of academic rigor and relevance to the contemporary challenges. I urge each one of you to engage actively, deliberate thoughtfully and collaborate generously. Let this conference be more than just an academic event. Let it be a collaboration of knowledge, a forge of partnerships and a platform for shaping the future. Before I conclude, I would like to extend my sincere gratitude to the organizing committee, the technical team, our volunteers and all those who have worked tirelessly behind the scenes to make this conference a reality. Your dedication and meticulous planning deserve special appreciation. In conclusion, once again on behalf of the organizers and on my own behalf, I extend a very warm and respectful welcome to each and every one of you. May this gathering be intellectually stimulating, personally enriching and professionally rewarding. Let us embark together on a journey of discovery, dialogue and development. May the blessings of His Holiness guide us towards greater accomplishments. Thank you all. Jai Shri Gurudev.
It's time to dive deeper into understanding. It is with great honor that I invite Dr. Manjunath Kumar sir, Dean Academics, Technical Program Chair, ICKECS, to provide an overview with this event.
Jai Shri Gurudev. Submitting my pranams at the lotus feet of our Mahaswamiji. Good morning to all. With the blessings of our Puja Mahaswamiji, distinguished dignitaries on the dais, off the dais, invited speakers, delegates, invitees, HODs and my fellow faculty members, a very good morning to all. Once again, I bid a warm welcome to 3rd IEEE International Conference on Knowledge Engineering and Communication System ICKECS 2025, making this conference a very truly exceptional one. This conference was provided all of us a unique opportunity to participate, present and discuss the concepts, emerging trends, techniques, new developments and the experiences in knowledge engineering and communication systems. We have received 1234 papers. Among these 1234 papers, we have received 50 papers from the different countries. So from USA we have received 24 papers, Indonesia 8 papers, UK 5 papers, Bangladesh 4 papers, Philippines 3 papers and Malaysia 2 papers, Russia, Saudi Arabia, Sri Lanka, Iraq, from these countries we have received 1 paper each. So total 50 papers we have received from the different countries, and from India, from different states we have received 1040 papers. So maximum contribution is from Karnataka, then Tamil Nadu, Maharashtra and Andhra Pradesh, Telangana. So after receiving these many papers, then we have conducted a peer triple blind review process, and based on the result of the review process, we have accepted 295 papers for the presentation. We appreciate and extend our frank recognition to over 900 authors for their quality and innovative contributions. We had a great task of reviewing this large number of quality submissions, and we are indeed grateful to all the program committee members, conference secretaries, organizing chairs and external reviewers for their sincere efforts in reviewing these papers. Today and tomorrow, more than 20 technical paper presentations will be conducted in offline and virtual mode. The detailed program schedule and session schedule is given in your conference kit. Speaking, the success of this conference depends on the strong support and active participation of all the delegates. On behalf of ICKECS 2025, I wish you a pleasant stay at our campus with a fruitful outcome. Thank you all. Jai Shri Gurudev.
Thank you, Pujya Mahaswamiji and dignitaries. To begin our session, we are honored to have with us today the distinguished experts who will be sharing their valuable insights and perspectives with us. Without any further delay, let me introduce our guest. Now, I'd like to invite Mrs. Rashmi, Assistant Professor, Department of CSE, to introduce our honored guest.
Dr. S. Somnath is a renowned Indian aerospace engineer and a former chairman of ISRO. Joining ISRO in 1985, he played key roles in PSLV and GSLV projects and served as director of major ISRO centers. As chairman from 2022 to 2025, he led historic missions including Chandrayaan-3, a recipient of prestigious awards like the ISRO Performance Excellence Award and Karnataka Rajyotsava Award. He is the author of Niluva Kuchida Simhangal, Lions That Darken the Moonlight, inspiring youth to dream big. Dr. Somnath continues to contribute as a distinguished scientist and advisor. Due to unforeseen circumstances, we could not have Sir's presence here. However, we have received a voice message that we would like to share with everyone.
Good morning, Namaskar. Thank you so much for this invitation to be part of this conference being organized by SJCIT Institute of Technology, the third IEEE International Conference on Knowledge Engineering and Communication Systems, ICKES 2025. Really honored to be part of this conference. Let me convey my regrets that I am not able to be present physically with the conference, but I am very happy to share my message as part of this, and thank you so much for agreeing for it, and all the distinguished dignitaries on the dais and off the dais, and also the divine blessings of Sri Sri Dr. Balagantha Gandharvanatha Mahaswamiji, Sri Sri Dr. Nirmalananda Natha Swamiji, Puja Sri Sri Mangalanatha Swamiji, and also the speakers who are there today. My greetings to all of you who are part of this conference and who are going to present different topics and lead the sessions in the conference. My congratulations for organizing such an important conference in this domain of knowledge engineering and communication systems. All of us realize that these two domains are one of the emerging areas, especially the communication systems domain and also working on data and information, primarily on the knowledge engineering. Communication system has been evolving over the last hundreds of years in various ways. Today we have reached a level where we are able to send data at enormous amounts of speed, and today we are looking at how we can enhance the speed, improve the reliability of the data transmission, and also to prevent eavesdropping into the data, primarily to secure the data while in transmission. I think these domains are now slowly emerging, and continuous connectivity becomes one important topic of discussion in all data communication protocols. So much has evolved over the years. Today, the communication infrastructure that we have in the world are one of the wonders of engineering. It collects everything. Today, we talk about the communication systems in the terrestrial basis, also the communication across space, which also becomes the backbone of the terrestrial communication networks. And we operate on most of the frequency domains as we know today, and slowly moving over to the optical communication networks that are currently allowing very high data transmission to be possible. And more than that, today we are talking about 5G, 6G and better communication networks, where primarily you are looking at very high data rate to come to help us in terms of streaming of videos, education contents and entertainment. And this involves huge amount of engineering challenges, and equally important is the challenges in long distance communication. And these are being addressed as very important topics of research, where the infrastructure development has to take place in the country in permeating this capability all across the world and of course across the globe. And very focused research is happening in various institutions. Equally important are the capability that we need to develop for space as well. Today you know that internet is being available to each one of us either through the cable connection or the Wi-Fi networks or the radio networks that we have today. And in the coming days it's going to be from the space. Satellites are directly beaming the internet services right now to devices which are kept there in the ground, and which have capability to beam steer and then receive those signals in a continuous manner from the fast moving satellites. And over the years it is going to change over to direct to device communication networks, and I am sure in the days to come it will also become optical, where more high throughput and more secure communication will be possible. Another domain is the quantum encryption of these communication networks to prevent eavesdropping and also to make sure that security of communication is protected. And knowledge engineering is equally important at this moment, because we are looking at huge amount of data collection across communication networks, and this data comes aggregated somewhere, and working on this data and to make a knowledge out of it is something very phenomenal. I think the data finally becomes knowledge and later becomes the wisdom of the humanity, and this process is something that we are talking about knowledge engineering, I believe. Here the contributions of scientists, technocrats into developing AI and other related technologies becomes very important. Looking at patterns, earlier we were limited to that. Now the patterns give rise to much more complex information domain, which goes into every life of what we have. Today it goes into learning, it goes into medicine, it goes into inventing new materials, it goes into inventing new medicines. So I think it has become a time that we need to look at it more seriously, develop our own capability in both these domains within this country, and very happy that conference of this nature sponsored by IEEE and SJC College is really bringing capable people in front to discuss and then collectively develop competence and capability in this country. My congratulations to everyone who has organized this conference. Wish all the best for the conference. Thank you so much.
I'd like to offer my deep gratitude and thanks for this video message. To introduce our honored guest of the day, Dr. Mahadeva Prasanna. Dr. S.R. Mahadeva Prasanna is a director of Indian Institute of Information Technology, IIIT Dharwad, and a professor in the Department of Data Science and Intelligence Systems. He holds a PhD in Computer Science and Engineering from IIT Madras. With over 20 decades of experience in academia, Dr. Prasanna has held key positions at institutes such as IIT Guwahati, IIT Dharwad. His research recognition interests span areas such as speech processing, machine learning, deep learning, and pattern recognition. He has published extensively over 159 publications and significant citations in prestigious journals. A senior member of IEEE, Dr. Prasanna has been recognized with several awards, including the National Award for Teachers in 2023. I take privilege to invite Dr. Mahadeva Prasanna to deliver his address.
His Holiness Jagadguru Dr. Nirananda Mahaswamiji, dignitaries on the dais, off the dais, all the participants of the conference, and the participants who have come from out of station to witness this conference. A hearty welcome to this conference. I am happy that such a very relevant topic, knowledge engineering communication system, has been taken as a theme for this conference. I know my close friend Dr. G.T. Raju is a person of sensing future always. Naturally, this would have come as his brainchild. So, as all of us have going through the era of technology disruption, where we are talking about data science and artificial intelligence, knowledge engineering and communication systems play a very important role. So in this connected world, as our Somnathji mentioned, where data gets generated at an unprecedented rate, at a very instant of time, lot of data gets generated in the digital form and gets stored. As a result, if this data in this connected world, when you take this data, processing them automatically, because manual processing by humans, it is impossible task. Naturally, we need methods for automatic processing and deriving knowledge out of that and drawing some inferences or conclusions. They are very important to propel our modern world to the next generation. So in this direction, if you just take already with Industry 4.0, lot of digital data getting generated, and industry people are clueless on what to do with this data. So in that way, data has no meaning unless you are not converting that into knowledge. So that is where the role of knowledge engineering comes into picture. So to harness this knowledge, the process of deriving the knowledge from this data is the ambit of the field of artificial intelligence. And the data science itself is getting the data, collecting the data, harnessing them, processing all this ill-posed data and make it available where trillions of data points are available. From there, automatically learning the information and convert them into knowledge, which is useful for the furthering of the human society. That is where the role of artificial intelligence comes into picture. So in that way, this knowledge engineering is a much broader umbrella term under which the most prevalent data science and artificial intelligence are viewed at the first level. But below that, if you go one layer lower, all broad areas of engineering and science can be included. Of course, any new technology disruptions we are seeing in the last 2 decades, the application areas has to go to the society and all other branches of engineering. If you consider the broader application areas of artificial intelligence, data science, knowledge engineering, it has to go to the broader science of science and technology. That is where all the papers that they are going to present as a part of this conference will make I am sincerely hoping they will make a significant contribution towards the process of knowledge engineering and communication system. I wish you all the best for the conference organizers, and I hope more and more such conferences will be organized where we increase the quality of the publications and works as we progress from one year to the other year. Thank you all. Few points I mentioned in the inaugural function. I'll just augment them with few slides. So essentially, as I was telling, when we are considering this knowledge engineering, it essentially deals with the interplay of these two fields of artificial intelligence and data science. So how we can effectively make use of these two verticals, this knowledge engineering and data science, to bring new innovations in the field of knowledge engineering. So suppose I think all of you might be knowing, if you take a dictionary meaning of the word knowledge, it is nothing but it is information and skills. It is acquired through experience or learning. That is the knowledge. We all as humans, we acquire knowledge through our experience or learning. And knowledge engineering is you have to design and develop such systems, artificial systems, which can acquire and learn knowledge from data. Okay, so that is what it is, that one. And if you go to the kernel of the knowledge engineering, so it will have artificial intelligence and data science. These two are the two fields which are required to build any knowledge engineering systems. I just briefly mentioned, suppose if I take industry 4.0, one takeaway from that is lot of digital data that is being generated. People do not know what to do with. Whereas when I go to industry 5.0, which is now knocking the doors, the purpose there is to build knowledge engineering systems. How do we derive knowledge from the huge data that we collect? So that is where this knowledge engineering is going to play a very crucial role in the new industry 5.0 that will be coming up after this 4.0. Of course, if you take data itself, data, these terminologies will come. Data is nothing but a factual information or measurements that you are going to collect from any digital processing systems. And once you have that, now we need to build models which are using this data and learning the information. That's why they are called as data-driven models. Because there is no human intervention possible here. From the data, raw data, it should automatically process and learn the information or model the information. That is what they are called as data-driven models. And we are talking about data-driven products. Of course, we use extensively this product, but of late, they are categorized under this nomenclature of data-driven products or data products. For example, the online shopping that you do using Amazon, Flipkart, or tickets that you book, online ticket booking, these are all data products, which essentially, once you, based on some knowledge, once you build the system, the further refinement of those systems is based on the data that it collects. 365 days, 24/7, lot of data gets collected when you are operating or using that systems, and those data will be processed automatically in the back end to get the next versions of the systems. That's where the data products we are talking about. Even though we are, I am given some simple examples which you extensively use on daily basis, but this is going to be the reality for any new engineering system that you are going to get. For example, if you take electric vehicles, you have a lot of sensors inbuilt into the EVs. Once you are collecting the data, how do I continuously process the data and derive the knowledge which may be of useful for human operator? So in that way, that can also be treated as a data product. So in that way, in future, everything we view in terms of data products, which are nothing but a system developed by knowledge engineering. Of course, these terminologies you may be knowing. We use these terminologies interchangeably: artificial intelligence, machine learning, deep learning, and data science. When you see the original coining of those terminologies, they were meant for certain purpose. If I take the field of AI, it is essentially to develop methods which can mimic some of the intelligent activities of humans on a computing machine. Machine learning is you enable the learning capabilities, mimic the learning capabilities of humans on a machines, which essentially when you feed with data and features, it will try to learn the information. And for example, deep learning is a specialized version of machine learning where you learn such information from large models, which are deep neural network models we do. And coming to the data science, which is nothing but a disciplines for collecting, organizing such data, which is be useful for AI. Of course, now you will be aware of the fundamental difference between machine learning and classical programming. In classical programming, essentially there also you are using data and you also have program. Machine learning also you have data, you have program, but there is a fundamental distinction between the two fields. If I go for classical programming, whatever you do, which is essentially you have a set of unambiguous instructions and data is there. According to that set of instructions, the data get processed and you get the output. Whereas when I go for machine learning, I will try to dig out some insights from the data. That is the very purpose of the machine learning. That is also a piece of code only. However, it will be more probing into the data and learn the information. That's how I would like to put machine learning as a differentiation with reference to the classical programming. So suppose if I take the traditional machine learning, what we used to do is you have the raw data from any system, digital data get collected. There will be a human operator as a feature engineer. He or she spends a lot of time in devising methods for extracting relevant features from the data, and that holds the key for a better performance of the machine learning system. Once you extract the features, the extracted features are available, which is essentially they are more discriminative compared to the raw data, because raw data will be highly variable in nature, and we want to extract the discriminate information, and those we are calling it as features, and those features are fed to the machine learning models, which will essentially try to learn the relationship between the input output data, or if you don't have labels among the data point itself, some discrimination like clustering tasks, and you get the machine learning output. Whereas when I go to the deep learning, you can observe that there is no feature engineering. You can apply raw data directly into the deep learning model, and through several layers of learning, you get the required machine learning output coming as the output from the model. Now, suppose if I take deep learning model, which are nothing but deep neural networks, these deep architectures whose predecessors are nothing but neural networks are shallow neural networks. So compared to shallow neural networks, the deep learning models have much more capabilities in terms of learning the information. So that capability came because of certain, if you look at the architecture point of view, some basic terminologies and basic principles, you borrow it from neural networks, but the capabilities of deep learning models are much more higher compared to what neural networks can do. And that is what was discovered by, I think this year Nobel award winner Geoffrey Hinton. His group came up with a method for learning such large networks. Once that was published in 2006-7, once that was published, rest is history. The whole field of AI and data science came into the forefront in the last 2 decades. Earlier, why deep learning did not work? If you look at the basic essence of the architectures, they follow the essence of neural networks. However, when they expanded, the architecture did not work. The reason is we were unable to train such large networks. Okay, that was the major reason, and there was insufficient training data. Now, in the current generation, when we are training, suppose if you consider ChatGPT or large language models, which are well-known products of AI and data science, the amount of data that they use for training such models is humongously large. Such data was not available at that point in the digital space, and also it was not possible to train, unable to train, insufficient data at that point, limited computing power. All these things had a trouble in making the deep learning models a reality, even though basic ideas were there from Geoffrey Hinton and other groups. Okay, but whereas turn of the century, we got abilities to collect more amount of digital data because of the connected world. GPU computing power came. So as a result of that, and also they came up with a strategy for training deep learning models. Because of these 3 factors, they were able to show learning the models. Now still we are wary about what revolutions this AI and data science are going to create for human society, but we can't avoid it. For example, if you see the generation, I think Pujya Swamiji was also telling in the morning in his remark. So we were doing manual labor. When mechanical systems came, people felt manual labor will be replaced by mechanical, but for more efficiency, people have moved into mechanical systems. When electricity came, people moved into electromechanical systems. Then they got computerized electromechanical systems, all computerized systems what we are using now. Now, what we are talking about, AI-enabled computerized electromechanical systems. That is where we are standing. I think since AI is going to add more power in terms of deriving the knowledge from a large amount of data, it is inevitable we have to move towards this AI-enabled computerized electromechanical systems. You can only delay it, but if you delay it, you will be the loser. So that is how the whole society is moving forward. Next. Of course, as I mentioned, in the last 2 decades, there are 2 disruptive technologies that have come. One is connected digital world. So the whole world is connected through digitally, by digital means. accordingly, data collection is very easy nowadays. Any application you have on the digital space, you get data. And GPU computing power is available. Now people are moving towards quantum computing, which is a much more computing power. So, and AI powered by deep learning is available, and data science field has emerged as a major field for collecting the data science. You can see, if you want to summarize what has happened in the last 2 decades, these are the things that happened, and these are going to propel and drive the industrial revolution in the next decade or so. The way forward for the next industrial revolution, industrial 5.0, AI has become a major technology, okay, and which is helping data science in a big manner. Otherwise, data science field was clueless in terms of what do I do with large amount of digital data I have, okay. So accordingly, we can exploit this AI and data science field for knowledge engineering. We essentially any engineering systems you are going to build in the coming decade, they can be treated as knowledge engineering systems. So accordingly, for industry 5.0, this knowledge engineering will play a very crucial role. So that is where all of you will have bright careers if you realize the significance of these technology disruptions.